So we'll just wait for 2 to 3 minutes and then we'll start. So I hope you can see my screen, right? Meanwhile, if you have any doubt, you can just let me know. We can have a discussion. So this session is the extra session on the revision, overall revision and problem practice. So I encourage you to kindly be interactive in this session because this will be the final session, and hence you should ask or clarify all your doubts that you have faced or that is currently with you and you want to get it clarified through some problems or some conceptual doubts. You just can unmute and ask me so that we can have a one-to-one interaction and then possibly solve some problems on them. Yes. So any doubts? Yes. Any doubts? You can just unmute and tell me. No doubts? Yes. So kindly unmute and let me know your doubts. Any doubts if you have from all the weeks? Okay. So since none of you are responding, so what I have done, what I have thought, that I will take some important problems from all the weeks and we'll discuss all of them with you. So that what you can get is the concepts, you can again get them clarified and get a strong grip on the problem solving of all the weeks. So we will cover numericals from week 1 to week 12, important numericals, some example numericals which you may have already solved in your assignments. So those we can just get them clarified through the concepts, and meanwhile if you just face some doubts, you can just let me know. Please stop me anywhere if you want some detailed explanation, and then we can just discuss that elaborately. Okay, so that can be the flow, so that you can get a overall grip on the concepts. So first problem is on your screen, where you just have a problem regarding the ammeters and voltmeter. And if you solve it, then you will get some fundamental clarity on the concepts. So we have some readings where you have three circuits, where the ammeter and voltmeter are connected at different positions. And the readings are also given. From this, you need to determine the value of Rx, Ra, and Rv. So Ra means the ammeter resistance, the voltmeter resistance is Rv, and obviously the Rx is the unknown resistance value. So can you try it for a minute? Or just unmute? Can any one of you unmute and just let me know whether you can see all my screen, and just because this session needs to be interactive, right? But none of you are unmuting or interacting. I cannot understand on the what is going on the other side. Just any one of you can unmute and just speak. I hope my voice is audible, right? So what you can infer from circuit 1? Just because we have to solve many problems, I cannot give you more time because we have already solved such problems. So we need to be quick because now it should not take more time. So what you can infer from circuit 1, circuit 2, and circuit 3. Because you have 3 different variables and you need to just form 3 equations. And after that, it will be easy. So I already know that the voltmeter reading is 450 volt for circuit 1. So in circuit 1, this voltmeter reading and ammeter reading are already known. What can I write? Yes. So you have 3 variables and you need to form 3 equations conceptually by just seeing these 3 circuits. So you can assume this as Ra, this as Rv, all cases, right? But the position is different for the 3 circuits. But you know this voltage and this current in all the 3 cases. So in this circuit, this current, if I write it Ia, can be splitted based on the impedances. And that current flowing through the voltmeter times the voltmeter resistance will give the voltmeter reading. So this gives us one of the equations. In next circuit, let us see circuit 3, what you can conceptually say that this current we know RA, through RA, IA current is known, and the same current is flowing through the voltmeter. And that times the voltmeter resistance will give the voltmeter reading. So this is the easiest form of the circuit. So IA times RA is RV. Obviously, this IA will be different. And it is given that IA is 0.4 times RA. RA is not known, we need to determine. Equal to, sorry, it is not RV, it is V, the voltage across the voltmeter. Sorry, one second. I have some issues with the nomenclature. So IA times RV, IA, this is the current through the voltmeter times the resistance of the meter is the voltage across the meter. This is what I am trying to write. Now I know RV. RV is voltmeter reading 400 volts divided by IA is 0.4. So you have 1000 ohms because you need to answer in ohms. Now from circuit 2, you can write IA times Rx into Rx plus RV is nothing but the current through the voltmeter. Now that times the meter resistance will give you the voltmeter reading. Now you already know RV, already know IA, already know this voltage. So can any one of you just calculate for me what will be Rx? Any one of you? Do it quick, okay? So 5, from this we are coming to here. Case 2, circuit 2. So 5 times Rx divided by Rx plus RV, RV is 1000, equal to the volt into your RV. Is the 392. So what is Rx? Can any one of you tell me? So RV we know 1000 ohms. Now tell me Rx. Yes, what is Rx? Solve quickly, okay? It should not take more time now because you have already solved these questions. So I will also solve with you. So what should be Rx? So 392 Rx plus, or I can write it in a different way. Rx by Rx plus 1000 equal to 392 by 5000. So what I can write is Rx equal to 392 by 5000 multiplied by Rx plus 392 by 5000 multiplied by 1000. And then you have 1 minus 392 by 5000 times Rx equal to 392 by 5000 times 1000. Obviously, this will be Rx equal to, so 392 by 5 divided by 1 minus 392 by 5000. So 1 minus 392 by 5000 is 0.92. 392 divide 5 divide 0.92. So around 85 I am getting. 07 you can write. So that is your Rx. From circuit 2 we got. From circuit 3 we got RV. Then what is pending? Only circuit 1. Now you can write this current and this current. So this current times Rx will give the voltage across RV. Sorry, voltage across voltmeter. So this current is already known. So meter current times the Rx is the meter current times RA full voltage. Some voltage drop will be there across ammeter, some voltage drop across resistance. So IA times Rx plus IA times RA is the net voltage across the voltmeter. Yes. So IA times Rx plus RA will be the voltmeter resistance, voltmeter reading. So now I don't know one parameter, which is RA. So V by IA minus Rx will be RA. So calculate what it is coming. What you are getting RA as V by IA 450 by 5, which is 90. 90 minus this 82 point or 85.07. So RA is around 4.93 ohms. Okay. I hope everybody is getting this answer. So this was just a brush up of your voltmeter and ammeter problem. So now you compute RMS and average. Just a recap, and a strong recap is needed because such problems are very important for all your power electronics or any advanced studies when you are doing in electrical engineering, any subjects. You need to calculate average and RMS. So you need to be quick in calculating all those things. And these waveforms are very common in electrical machines or power electronics: square wave, triangular wave, sine wave. They are very commonly used or commonly found waveforms for which you need to be quickly able to determine the average and RMS value. So can you tell me a method? I told you while taking the weekly session that this is your square wave, for example, and this is your triangular wave. And this is your sine wave. So three kind of waveforms. Let us call them y1, y2, and y3 as a function of time, obviously. Now, obviously, you know that it has two forms. Maybe it can be half wave rectified, so the negative portion goes off. Or it can be full wave rectified, but in full wave rectified form, the negative portion just goes above and becomes the positive lobe for this half wave symmetric waveforms. So can you tell me how to compute average and RMS? Average is easy. It is just mean over one time period of the area under curve. And this is mean over square of signal area under curve, but then you take a square root. So what it means is that for RMS, you need to first square the signal, then mean it over one time period, and then you need to take the root finally. So always it goes reverse direction. First you do the square, then you do the mean, and then you do the root. But in RMS only you need to take the mean of the signal over the area. So can you tell me what is the area under this curve? if I only want to calculate the, for example, this is A, this is also A, the peak value, this is also A. If I average it over one time period, I will get 0. So average of the signals are 0. But average of the full wave rectified form, so full wave rectified form means the negative portion goes to the top positive portion. So it is just A only for the square wave. And for triangular wave, what it is? Like this. It will go top. And then if I average the area under the curve, so 1 by T and the area under the curve means this is A. So half into A into T by 2. Right? So T gets cancelled and it is A by 4. So for this is triangular wave. And for sine, I can write 1 by T by 2. Sorry, this will be T by 2, right? So A by 2 will be there. Can anyone cross check? For the full wave rectified form of the triangular wave, you need to mean over one time period, but one time period is now T by 2. So 1 over 1 by T by 2, and then you need to take the area under the curve, which is half into base into height. Base is T by 2, so this gets cancelled. So it is A by 2 for the square wave, for the triangular wave. And for the sine wave, what it is coming? Yes, anyone, please be quick. So similarly for sine, you need to do 1 by T by 2. Because now also it is like this. T by 2 it is repeating. Full wave. Integral 0 to T by 2 only. Sine of T dt. Please do this integration and tell me what it is coming. So basically you have 1 over pi and obviously some strength of the signal is A. Integral 0 to pi sine theta d theta. Because T by 2 is like this only, right? If the signal frequency is, I consider omega, then omega t is theta, then you can write like this. So it is minus cos theta and then 0 to pi, which is nothing but cos of 0 minus cos of pi into A by pi. So it is nothing but 2A by pi, which you already have derived in many of the problems. So 2 times signal peak by pi is the average value. But if it were the half wave rectified form, Then for square, this slope would have been 0. So t by 2 and then 0. So this is 0. So over one time period, what is the area? A times t by 2. Only this part is contributing. But I need to mean over 1 by t now. So it is now a by 2. For square, right? For triangular, like this. So 1 by t only now. But what is the area? Half into base into height. So t gets cancelled. Now it is a by 4. So as you see, 1 by 2 times of whatever was coming in the half wave rectified form. So it is coming half times because area is now half, right? That's why. So not only area is half, but the time period is also double. But the area, this part is not contributing anything. That's why it is coming half. Yes. So now for the sign, it will come as you know, Vm by pi. So A by pi for half wave rectified. But find the RMS. So for RMS, if I just so for RMS, if I take the half wave form and then full wave form, then the square will look like this. And in the half wave, the square will look like this. The triangular will look like this only, right? So the triangular will be like this in full wave. And the sign will look like this. But now we need to find the RMS. So RMS of this kind of constant signal is nothing but A. Because you need to square it, then mean it, and then root it. But it is a constant signal. So it will be A only. But if you square this kind of signal, where for example y equal to xt kind of signal, sorry, y equal to t, right? So if you squared it, it will be t square. So you need to integrate it, because for what is the steps? First you square, then mean over one time period, right? So better you just square it first. So how will it look? Do it geometrically. It will be looking like this, like a parabola. And this is t by 4. This is t by 2. right? This is fully your T. So if I can find this much, then I will just have to find again this, because this is one time period. So I need to square the signal, and then which I have already done, and then I need to find the area under the curve over one time period, which is T by 2. So find the net area under this much period, and then you need to just mean it over one time period and then root it. So can anyone do and tell me what it is coming? And that will give you your RMS value of the full wave rectified form. Similarly, you do that for the half wave also, and tell me what it is coming for the triangular. Do this, try in 1 to 2 minutes and tell me. Yes, any one of you got the answer? So if y equal to t, this point is my t by 4 whole square, right? At t equal to t by 4, it is t square by 16. So what will be the limit? Zero to t by 4, t square, right? One by t by 2, which is 2 by t times t cube by 3. And then you need to take the root for the RMS. So mean and then take the root. Are you with me? So I cannot hear, neither I can see any one of you. So can any one of you just unmute and let me know? Otherwise, there is no point. If you guys do not interact, then it is very difficult for me to understand.
Yes, sir.
So kindly solve this. So this much area is 0 to t by 4. This much of t square dt, right? And then you need to just multiply with 2 because you need this area also, which is symmetric. Once you do this, you get the net area of the square of the net area under the square of the curve. And then you mean it over the time period, which is 1 by t by 2. So what will be the final answer? Can kindly anyone can give me for triangular, half wave and full wave form? So in half wave, you just need to mean over 1 by t, not 1 by t by 2. Just that much difference will come. So tell me both the answers of full wave and half wave. And obviously you have a. That will be a square and one a will come. Some strength of the signal, that is. Am I missing something? Yes, I want the answer from you. So kindly, otherwise I will not proceed.
ठीक है सर, ये मिसिंग तो नहीं लग रहा सर।
हाँ, तो आंसर क्या है?
TA/2/√6 है सर, ये फुल वेव का।
और हाफ वेव का?
TA/4/√3।
यहाँ पे 2 भी है, वो ध्यान दीजिए। So I give you 2 minutes, solve. Just find the area. So we have considered slope as 1, right, for simplicity. So if slope is 1, can anyone tell me what will be this time period? A only, right? So instead of t, we can write a, just for simplicity. And this a will not come. So slope 1 is a generalized assumption. So just consider slope as 1 and proceed. And you get at the time t equal to t by 2. If we know that the signal peak is a, then obviously we know for the slope being 1, this is also a. Hope you understand what I am telling. So if this is a, then what can I write? One second. Yes, so for simplicity, we assume this has slope 1. So if the signal peak is a, then this time is a. So this time is also a, this much. So what I can write? Signal waveform is y equal to t, so square it, integrate it from 0 to a, the time, this much only. Then mean it over 2a. And then root it. Simple, this much is coming. Hope you understand why the limits are 0 to a. Because at signal peak being a, time at which signal peak will happen will be a if the slope is 1. So 0 to a, this much, integral the waveform, and then 1 by 2a. Because, and obviously multiplied by 2. So do this, you will find a by root 3, a by 3, sorry. Because this will be t cube by 3, 2 will get cancelled. And obviously 1 by a, so a will put, so a square by, a by root 3, sorry. And this one, if you do for the half wave, then that time will be double. Other part contribution is 0. When you square this, 0 square is 0. So you get a by root 6. Now find for the sign. So these two we have done. Please remember, okay? These two are important. Now do for the sign. So if you check for the sign, just remember the RMS over one lobe, or I give you one exercise, 0 to pi sine square theta d theta, 0 to pi, you just find this. How much is it? Just remember this result. 0 to pi sine square theta d theta. What is it coming? Then you find the area of one lobe of sine square. Then you know cos 2 theta equal to 1 minus 2 sine square theta. From there you can find sine square theta is 1 minus cos 2 theta by 2. So we have 1 by 2 minus cos 2 theta by 2, 0 to pi, and then d theta. So pi by 2 minus sine 2 theta by 4, 0 to pi. So this will be 0. And if you mean it over pi, then this will be 1 by root 2. And if you mean it over 2 pi, then it will be 1 by 2. So for half wave, it will be a by 2. And for full wave, it will be a by root 2, just as you know. So always remember this area is pi by 2. Area of 1 sine square theta lobe, I can write. Any doubts? So this is RMS, right, of the sine. For the full wave case, it was easy because you know a by root 2. But the half wave rectified case, it was a by 2. So now solve this problem. This is a simple problem we have discussed many times, but I thought it should be just covered once again to understand the units, how will be the dimensions of the resistance and resistivity for both the volume and surface, and with and without the guardrail. So solve this quickly. So what will be the surface current in microampere? So volume current and surface current you first find out. So if guard ring is present, what can I write? The current that flows is only due to this applied EMF is only due to the volume, right? So there will be no surface current because we have connected the guard ring. So how much will be the current? It's already given, right? Now, in absence of the guard ring, obviously only the surface current flows plus the volume current. So if absent guard ring, then we have both the currents. both volume and surface. So this current is sum of two. So what is the only surface current? 7 minus 6, which is 1 microamp. Now calculate resistance, volume resistance. So resistance is only ohms, right? So how can you calculate? The applied voltage divided by the volume current. So applied voltage 2 kV divided by volume current. So volume current is how much? 6 micro. So micro and kilo gives mega, 1/3, 0.33. Sorry. Micro is 10 to the power 6, right? So 10 to the power 9 times 1/3. So if you get in mega, 10 to the power 6 goes, 10 to the power 3 still remains. So 1000 by 3, which is 333.33 mega ohm. That is the volume resistance. Now surface resistance is what? Surface. So what is the formula? Same resistance. It will be volume by voltage by current. Surface current is 1 micro. So 2000 mega ohm. Right? Now give me the surface and volume resistivity. Now can anyone tell volume resistivity, surface resistivity formula? I want to hear from you. Along with the units. Formula along with the units. Tell me. Yes. I want to hear from you. I will not give. So kindly let me know the dimension, units, and the formula. Obviously, the formula will give you the dimension. Somebody please unmute and tell me. So resistivity, volume resistivity is rho V, if I write that in nomenclature, volume. So R equal to rho L by A. So rho equal to RA by L. Now let me charge it a little bit. Yes. So rho V volume equal to R volume L by A. So rho volume into A by L is R. But I need rho. So ohm into centimeter by centimeter square. Yes. So what will be the... Sorry. I wrote wrong. And none of you told me. So R equal to resistivity into L by A, right? What am I? So we need rho, RA by L. So ohm times centimeter square by centimeter. See, this is ohm centimeter. So for volume, we know this, coming from Ohm's law and the basic definition. So we have rho as RA by L. Now this is ohm centimeter. But this will be instead of... So surface resistivity is nothing but... Surface resistance is surface resistivity times length by peripheral length. Now what is this length and peripheral length? So this is basically a length only. So it is only ohms. So instead of area, we have peripheral length. and this length will be same. But can anyone tell me what is this area length and peripheral length based on the applied potential? I told you. Anybody unmute and tell me what is the length, what is the area, and what is the peripheral length? How to calculate? You have three terms. Now, how to decide? So, area is the cross-sectional area we are referring to, the perpendicular to the current flow direction. Now, current is, this is the current, and if it is flowing like this, then this area perpendicular to the flow of current will be taken. Now, how to decide the current flow direction? Based on the EMF applied. Now, current I saw, plus is here, minus is here, so current will flow into the frame, out of the frame I can say, like this, and the area perpendicular will be this. So this area you need to take, and this area you need to take means that L into H you need to take. So area is L into H, cross sectional area. Now what is L?
W, sir.
Yes, so L is W, because that is the path it needs to, current needs to travel. That is why the resistance is developing. So the channel width I can tell, or the insulator width. So AL all done. What is remaining? Peripheral length. What is peripheral length?
2 into L plus.
So 2 into L plus H, right? Understood? Because this is the surface current, right? This is due to the which the surface current is flowing, right? Otherwise, this is the volume current. So L, H, W, all we know. You plug in all the parameters and determine from these two formulas and tell me how much is it coming. So surface resistance we know, volume resistance we know, and volume resistance times A by L will give you volume resistivity. Surface resistance times peripheral length by length L will give you surface resistivity. Tell me both these things, how much is it coming? Let me bring this here. So A equal to L times H. L is this much. No, capital L. Please don't confuse with small n and capital L. Small L is W. Small L means the path that the current needs to travel is nothing but W. This capital L is different, okay? And now L into H is the peripheral length. Multiplied by L plus H multiplied by 2. And we know that L, capital L, H and W are given. Calculate both. Rho V, rho S, you calculate. So this will be calculated in mega ohm centimeter, and this will be only in mega ohm, because this dimension you see will cancel and the surface resistivity and resistance all will be in ohms only units. So give me answer quickly from these two formulas. So check current flow direction based on applied EMF. It is important, right? Calculate the two values. Please be quick, okay? These do not should not take more time because we have more problems to cover. Please be fast. So how much is it coming? One of you should unmute and tell me the answer. Otherwise, how can I proceed? I cannot just proceed because if someone of you have doubt, at least one of you should unmute and give me the answer. Otherwise, I cannot proceed because none of you are just unmuting and solving. Just simple plug in the values. RV and RS you already know, right? Just calculate it sometime before. RV you calculated as 333.33 and this you calculated as 2000 mega ohms. So plug in both and then give me the value. Just note this is in centimeter, so you need to convert in meter. Please be fast. I want to hear the answer from you, otherwise I cannot proceed. So done? If you check, you will get
Sir,
1000.
first
Yes.
answer is 13,333. That
Uh,
volume resistivity.
volume resistivity is, let me check. Okay, volume resistivity, how much you are getting?
13,333.2 something.
Okay. So this is 10 to the power minus 2 and 10 to the power minus 4. So divided by. No, check correctly. See, rho V, what it will be? 333 mega times A. A is what? L into H. L means 80 into H, 20, right? Into 10 to the power minus 4 divided by your small l, which is nothing but W. And W is 40 into 10 to the power minus 2. So you give me in mega ohm centimeter only. No issue. No need to convert to meter. So this is centimeter square. This is centimeter. You give me in centimeter only. No issue. So 333.33 times 80 times 20 divided by 40, right? So it is 13,333, right? Mega ohm centimeter. Yes, I think you were correct. So now, what is the surface coming? So this is the volume, right? So surface is 1000. If you calculate, you can just check. Everyone getting 1000 mega ohm? Simple, right? 2 into L plus H you do. And times RS is 2000 mega. And this is in centimeter divided by length. Length is W, which is 40. So centimeter and centimeter will cancel, and then you can get 200 times 2000 divided by 40. So which is nothing but okay, so I am getting 10,000, sorry. 10,000.
Right.
Okay. So now let us go to our next problem. I hope the problem is visible. So first one is very direct question. So but be careful where the voltage is applied, okay? Because then only you can write this by this equal to this by this, okay? So just simply you can write Q by P is R by X, or Q is 80 by P 120 equal to R by X, just the balance condition. So I am getting 120 into 120 by 80. So 180 ohms. So everyone knows how this proof comes? Yes?
Yes, sir.
Yes, how it comes?
From the balanced condition.
No, I agree, balance condition, but how it is derived? What do you mean by balance? What is meant
Both
by
the
the
both the
current through
arms.
the voltmeter, or sorry, the current through the galvanometer is 0.
Yeah.
So what it means by the term that the current through the galvanometer is 0? That means the voltage at this point, let's say N, and the voltage at this point, let's say P, are same. Right? That's why your current is 0, right? So from there you can derive by joining these two that when the galvanometer current is 0, then what will be the value of R? Then you can find R as Qx by P. From there it comes. So what will be R such that this point potential and this point potential are same? So you can just derive accordingly. But the condition comes from the fact that the potential of these 2 points are same. So you find the potential at this point as a function of these 4 resistances, and you find the potential at this point as a function of all these resistances, and obviously E. But since E is at both sides, it will get cancelled, and a relationship will develop between these 4 parameters. And since R is the variable, you get R as Qx by P. Now calculate the error. Inaccuracy, it is then obviously there are 3 known parameters, Q, X, and P. Sorry, X is the unknown. Okay, so X is PR by Q. So PR and Q are known, but known with 2% inaccuracy. Okay, so 2% may be error. But then what will be the error in estimation of X? So you know that product or your division we discussed, relative error gets added. and addition or subtraction, absolute error gets added. But what we have been given, these are all relative errors as a percentage of some actual thing. So relative. So then we can add. So what you add, but in division also you need to add. Okay. Only add. So then 6%. Easy, right? Then calculate the next two. Calculate the next two. So resolution is being asked, right? Resolution is R can be varied. 1 ohm step. So P and Q are fixed and a 1 ohm step is given. Delta R, so delta X. So we get the delta X as a 12 by 8 you calculate. I think it should be 1.5 now. So 1.5, right? See the next one. I hope there is no problem in this, right? It's simple. If X is PR by Q, then delta X is P by Q into delta R. Then delta X is the least count or resolution. For the least count of R being specified, you can get the least count of X. Or delta X you can calculate. But you will know this, delta R is 1. So P by Q 120 by 80 into 1 is delta X. So now I give you one problem that the required value of E is being asked. At that point 1, X increases by 0.1 and I need the value of E for which this galvanometer will produce 10 microampere current. So meter resistance is known and all the resistances are known because X you have determined to be 180. But now X is 180.1. Other resistances are same. P is 120, U is 80 and R is 120. But X is now 0.1 more than the usual value. So it will lead to unbalance. So you have been asked to calculate the value of E for which the current through the meter will be 10 microampere. So calculate the current through the meter. So to calculate the current through the meter, you can just open it and calculate the Thevenin equivalent across these two nodes. So I can do it in a fresh page. So why Thevenin equivalent? Because if these 2 points are disabled, wherever you want to find the current through, you disable that point and find the equivalent resistance across these 2 points. So this will be shorted to find the equivalent impedance. So what is the resistance? You have like this. Where two resistances are connected in parallel. So this one will shorted, means P and X are connected in parallel. And then another node you have where Q and R are connected in parallel, right? Sorry, not this one, but let me draw it a little better way. So I remove the meter and then I have P and X connected at this point. And obviously Q and R. So if I see from here, these two are connected. So P parallel X and series with Q parallel R is the Thevenin resistance. And voltage across these 2 points is nothing but E into, if this is 0, then this is the voltage division rule. Just open the galvanometer and check. E times X by P plus X minus, so this is node P voltage, and then N voltage is E times R by Q plus R. So this is the Thevenin voltage. Now E value is unknown, but this value will be known, Thevenin resistance. So the network will be looking like E. Then you have some Thevenin resistance. And then you have this RG, meter galvanometer resistance. So galvanometer resistance is 1000. So then you can calculate IG, but IG is given 10 micro. But I need this E, for which this becomes 10 micro. So E is unknown. So this E divided by this Thevenin resistance plus 1000 will give me 10 microampere. So if you calculate this Thevenin resistance, can you calculate? P parallel X plus Q parallel R. And P, X, Q, R all are given. So you calculate the Thevenin resistance, it will come out to be 120.015 ohm. And then you have the equation of Thevenin voltage. So this is not E, okay? This is Thevenin voltage. V Thevenin I can write. This is the Thevenin voltage. This. So V Thevenin, it is not E, okay? Because this is the Thevenin equivalent network. So V Thevenin will come from here, this term. So this term divided by your Thevenin resistance, which is 120.015 plus 1000, will give you 10 microampere. But this has E. So once you solve X, P, X, R, Q, all are known, right? So from here, E can be derived, and I will give you the answer. E is around 84 volts. So it was a bit lengthy, but still you can get the concept. So now calculate this one, this question. This is an interesting question where you have the compensating coil connected. Here is the compensating coil. Try and then I will discuss with you, okay? So basically I need this current, right? To calculate the power supplied by the source, I need this current. So how to derive this current? Based on the impedance of the network. But you have the compensating coil, right? So can anyone tell me what will be the function of the compensated coil wattmeter? Please unmute and let me know.
So to maintain the current in balanced condition, pressure as well as current coil.
Yes, can you repeat?
So to maintain the current under balanced condition in the current as well as the pressure coil.
No, not balanced condition. It reduces the loading effect. For which if your pressure coil is connected like this, so there exists some current being drawn into the pressure coil, right, which is unwanted. So to negate the drop, what I can say, to negate that drop, we inject opposite, that is the coil, whatever you are having, this coil is having some resistance. So that resistance drop you want to compensate for, so that the loading effect is not observed by the measuring instrument. So that is what for what we use the compensating coil. So after this, you just need to calculate the resistances and then check the current, and then current times the voltage will give you power from the source side, and then load side also voltage this side and multiplied by current this side, or voltage squared by RL, or current square times RL. This will give you load power, and source power will be similarly Vs times Is. Vs is E, or yes, or Vs square by Rs, or Is square times Rs. Rs is the virtual effective impedance of this network. So how to calculate? You tell me. Simple, right? You just observe that power of the source can be calculated as V square, which is this voltage, divided by R of the equivalent network. So what is R? You have the current coil in series with the parallel combination of load and the pressure coil. Sorry, parallel combination of the load and the pressure coil, because load and pressure coil are parallel. So parallel them and series with the current coil. That will give you the net impedance. So V square by R net is equal to power supplied by the source. You will get that as 73 watts approximately. And load power, similarly, you calculate this voltage or you calculate this current. So how to calculate this current? First you calculate this current, which is nothing but E by this one only, similar, RL parallel RPC. RL parallel RPC plus RCC will give you, E by this will give you this current, input current. And then you divide that current among RL and RPC. So inverse, right? So current gets divided and this will give you the load current. And load current square multiplied by RL will give you load power. So you'll get load power as 56.25 watts. Just check, okay? So it was simple, okay? No complexity was there. It was a direct question. You just only need to calculate the equivalent resistances, and then only from that you can calculate the powers on both the sides. So now you calculate this problem you do from the galvanometers. From potentiometer, you see this galvanometer current when it will be balanced, and from that balance condition you can answer all the questions, right? So from the null position you can tell the resistance of the wire R is being asked, and then it is told in the part B that if the jockey is moved rightwards through a distance of 1 ohm from the null position, then the test current in the galvanometer is being asked. So you determine the R easily by net voltage applied divided by this R, and you divide it accordingly, right? So net voltage applied is known, and you want to know this much voltage. So it is R divided by R plus R test, right? Okay, first I need to determine the null position, right? So can any one of you tell me how to determine the null position? Any idea? Yes, how to determine the null position? So what happens actually at null position? Can anyone tell? Current through the galvanometer becomes 0. So what is the voltage across these two nodes? If current through the galvanometer is 0, it is nothing but E test, because no drop will be there, right? So full voltage will appear across these two nodes. So I know E test is the this much drop. So E test is nothing but E supply divided by net this resistance, which is RAB, is the current, times this R. So now I need R because I know this potential is E test. So R is E test into RAB by E supply. Now E supply, E test, RAB all are known. E test is 2.64 and RAB is 10 ohms divided by E supply 4.4 volts. So R is 6 ohm, right? Now I see that the jockey is moved to the right by 1 ohm position, okay? From the null position. Rightward it is moved more by 1 ohm position. Then the I test is being asked. So can you calculate? Now it is an unbalanced scenario, right? So from the null position, this J0, it is moved to J1. Rightward. So you need to calculate this I test. Yes, so what can I do?
E test by total resistance. R test resistance plus R plus 1 ohm, sir.
But that will not work because this side also has a current, right? This side is also driving current. And this side is also driving current. It is unbalanced condition. So both sides have their potentials and are driving currents. You cannot determine what is the actual current being driven by this source. Why? Because this source will see this plus some currents of this supply. So the potential across these 2 points will be governed by this one. So we need to determine the potential across these 2 points. Correct? And to find the potential across these 2 points, A and J1, at J1 position, right? We need to apply the Thevenin rule. Because that will give me the equivalent voltage at that point. And once I know this voltage, then I can just apply the circuit theory. But this voltage is important. So V Thevenin is nothing but E times E supply times, you open this loop, E supply R by R plus net resistance, right? This much voltage, right? By removing this. Now it is shifted to the right. Simple voltage division, right? And what is R Thevenin? R plus 1 parallel with you just see this point is A, this point is J1, and this length has R plus 1 resistance. But I need to short this one also. I opened this one and short this one. So this is, I think, 10 minus R plus 1, and I shorted that with this. So both comes in parallel. Right? So you know VThevenin, you know RThevenin. Now it is okay to plug in the remaining part of the network. So VThevenin is known, RThevenin is known. Now you connect the meter and the E-test to calculate the overall driving current IG. So you have E-test minus VThevenin divided by RThevenin plus R-test. Just basic network theory, right? And this meter you assume very low resistance. So VTH minus ETH you write, or just calculate the mod. So either you do ETH minus E-test minus VTH by net resistance, RTH plus R-test, or you do the reverse, but the current magnitude is only needed. Okay. So it will come, if you do, it will come around, but with proper sign is given, right? So see what we did. Okay, so they have not specified. No, they have specified. Okay. So if current direction is specified like this in the exam, 1 second. See, they have already specified a direction like this. So it is out of E-test. So the direction I have mentioned is reverse. I hope you are getting what I am telling. They have already specified a direction for you. So you cannot draw your own direction. You have to go ahead with the same direction. So E-test positive terminal is here. It is out of this. So and this is VTH. So E-test minus VTH it will be. Or test. And then you will get the value as minus 61.97 milliamps. Minus sign is there. And VThevenin and RThevenin value will come out to be, I am writing 3.08 volts. VThevenin comes from here and RThevenin comes from here. RThevenin is 2.1 ohm. So VThevenin is like this. This side has positive node. So the polarity will reduce this side. So this will be VThevenin. So you see VThevenin and ETH oppose each other. So when you find VThevenin, RThevenin, you just plug it in with E-test and R-test with the correct polarity. And then you can write I-test in this direction because it is already specified. And then I-test will become E-test minus VTH divided by RTH plus R-test. Okay. So let's go to the next problem. I think the problem is visible on your screen. So a sharing bridge is given and the parameters C1, C2, R2, R3 are given and Cx is being asked. So basically you need to apply the balance condition. This is Z1, this is Z2, this is Z3, this is Z4 and you can do Z1 by Z2 equal to Z3 by Z4 because the voltage is applied here. So this by this is this by this. And then you can just calculate because Z1 you already know. Series combination of R and C. And C is to be written in XC form. So XC is 1 by omega C. And from there you can just equate the real and imaginary parts and get Rx and Cx. So Rx if you calculate will come out 125 ohm and X Cx is nothing but 2 pi F. So into Cx. So omega you can write like this and 60 hertz it is given. So Cx value can be determined, okay? So I will give you the answer of Cx. .28 microfarad. Just by equating these real and imaginary parts, you will get it. You can check. Now dissipation factor. Dissipation factor you can calculate. I already talked a lot about dissipation factor because these are Rx, this is 1 by omega Cx. And dissipation factor is due to this one, the active part. So this theta is nothing but okay. So what can be the dissipation angle? Can anyone tell me? So dissipation factor is nothing but tan of some angle. If that angle is more, I need dissipation to be more. Now can it be this angle? If this angle is more, is this dissipation base increasing? No. But if this angle is there, then if this angle is increasing, then this Rx is increasing, active part. So Rx increasing means more loss, more dissipation. So this angle will be there. So tan of this angle. So it is Rx times, or else you can check it to be directly correlated with Rx. R should be in the numerator because R causes the dissipation by 1 by omega Cx. So it is nothing but D. It is omega Cx times Rx. And this will give you the value of dissipation factor. So omega you know 2 pi into F and Rx and Cx you know. So dissipation factor will come out 0.06. So all will calculated, right? Now you see to reduce the error ratio of the CT. So CTs are connected generally. So one turn here and more turns here to reduce the current. But these are connected in series to the line. Now if the current, I draw the equivalent circuit, then we have a magnetizing part and there is the primary. So the current is coming like this and here the transformation of the current is happening. So if this current is to be measured, incoming high current, let's say 1 kilo ampere, and I have the transformation happening here. But if this current is more, magnetizing current, then I lose something. So this should be low current to for more accurate, for better accuracy I can write. So very low magnetizing current should be drawn from the line such that most of this current to be measured goes here, and hence we can record transfer. So very low. Similarly, just read these two problems. Maybe I can bring both the problems here side by side so that you can better see them. Yes, what should be the answer? So I cannot leave the CT to be open circuited, right?
B होगा.
Then it will saturate the core of the CT and it will lose its characteristics. So I cannot open it, right? So this B. But what about this one? I can open circuit the PT secondary because PT is connected parallel to the line. Parallel to the line. So no fear of saturating the core because it is connected parallel to the line. It is impressing some voltage. So I can open just like the transformer. So both can be done. So now see this problem. So we have wherever you see negative feedback, apply virtual short. Why you can do like this? Because even if this voltage increases, this voltage cannot increase. But if this voltage increases, this voltage will eventually become positive. And one becomes positive, so what I'm telling, sorry, if this negative voltage increases, negative side voltage, negative port voltage, I can tell. One second. It is very interesting. If this is the inverting node, right? If this voltage increases, then you will go to hit the minus VCC, and then it became lower than this. So it became higher than this because VP is greater. So again, it will be driven to equalize with VP and VN. That means a feedback loop, negative feedback loop will act in order to pull VN equal to VP. Why pull? Because see what was happening first. VN increased, for example. Then that became negative and pulled VN down. So it became 0. And again, if VN reduces, Reduces means it became lower than 0. Then this became higher and again it pulled it up. And as soon as it pulls it up, we can apply virtual short because these two will ultimately equalize. Okay, because a feedback loop is acting. Feedback stabilizes and prevents saturation. So you can apply the virtual short here. Apply and let me know what will be the voltage. So I can assume that this is 0 volts. And no current will flow into the op-amp. So I can apply KCL basically 2 by 4000, this current plus this current. So into 2 is nothing but V0 by, because this side is at higher potential, I am assuming. So 0 minus V0 divided by 1000. So V0 is nothing but minus 1 volts. Now you calculate upper threshold, lower threshold and hysteresis band for the Smith trigger circuit. See, positive feedback is there. So a Smith trigger arrangement. Calculate this from the constraints. You need to calculate the threshold points, and the hysteresis band is nothing but UTP minus LTP. So these kind of problems we have done a lot, many number of times, I can say. So you need to find the condition. Let's say VP and VN. Now when VN is greater than VP, then V0 toggles from plus VCC to minus VCC. And if VP greater than VN, then V0 toggles from minus VCC to plus VCC. Now we know this. From these two constraints, you need to give me the bands for variation of input voltage, above which the upper threshold is reached and below which the lower threshold is reached. That means the toggling happens. So V in condition you give me. That for what value of V in, V out toggles from plus VCC to minus VCC and minus VCC to plus VCC. Obviously, V in should be low for the toggling to be negative. Sorry, V in should be high for the toggling to be negative and should be low for the toggling to be positive. So this point is at VP. Now all the currents will flow like this. No current can enter here. So what I can write is VP as V0 minus 3 volts is the net voltage across these impedances divided by 25 plus 5 kilo is the current times 5 is the drop plus 3, because this is the offset, right? So 3 plus current times this resistance is the drop, and hence you get this as 5V out minus 15 divided by 30K plus 3. Got it? Or else you could have applied KCL also, that this current equal to this current. So tell me the toggling condition. Okay. I'll write it in a fresh manner. So tell me the condition on V in for which the output voltage toggles. You know that no current is flowing into the op amp. Yes. Are you doing with me? So this will be the last problem, okay? So kindly tell me the two constants and then we are done. Anyone doing? Hello? If you are doing, kindly let me know. So what will be VP? So V0 minus VP by 25 is nothing but VP minus 3 by 5. So V0 minus VP is nothing but 5 VP minus 15. So 6 VP is nothing but V0 minus 15. Potential is there. So I need the condition on V in, right? So if someone can tell me how to calculate, I can understand whether you are with me or not. Otherwise, I can simply write the answers for you, but that will not help, right? So whatever am I doing, you should understand that. So you should tell me what should I do. I will not write. I think nobody is with me. So I am writing down for you. So you see VP is, again I am doing the same thing because you are not doing. So simply you write down this 25 equal to VP minus 3 by 5, and then you have 5. So V0 minus VP is 5 VP minus 15, and 6 VP is V0 plus 15. And from here you get, see, what is the condition? So VP is V0 plus 15 by 6. Now if VP greater than VN, you have what? Minus VCC to plus VCC. And if VP less than VN, what you have? Plus VCC to minus VCC, because you know that when VP falls low, VN rises high, then the negative toggling happens. So initially what it was, if VP greater than VN condition I want, then minus to plus toggling happens. So initially I have minus, so minus 50. So V in should be less than 0. But from same thing, VP, so one condition done. Another condition is VP less than VN. So Vp is this less than Vn. Vn is Vin. When Vp less than Vn, then plus VCC goes to minus VCC because Vn rises. So plus VCC to minus VCC. So initially it was plus. So 5 plus 15 plus 15 by 6 will give you 5. It's less than Vn. So Vin should be greater than 5 for that. So you see when the Vin goes high, negative toggling happens. When Vin goes high, negative toggling. When Vin goes low, positive toggling. This should happen because Vin is at negative port. Whenever Vin rises, the negative strength goes high and the negative toggling happens. Means plus to minus. And Vin goes low, then the negative strength reduces. And as the negative strength reduces, the positive toggling happens. Means minus VCC to plus VCC. So it gives you with two conditions that V in, the condition on V in is V in should be either less than 0 or V in should be greater than 5. So the UTP is 5 and the LTP is 0. And this gives you the band as, hysteresis band as 5 volts. So that is because 5 minus 0, UTP minus LTP is 5. So this is the simple thing. And for this, you know already that the flash type ADC is the fastest. And because it needs only one clock pulse, the successive approximation type is followed by, and the slowest is this 2 to the power n. And this needs n clocks. So point D is the correct option. So flash is the fastest, followed by this and then this. So this kind of problem I think you have already done. So there is nothing in this problem. So you can try. If you have time, you can try. Or else I can just write the answer for you. So PMMC reading 7 volt is given and the current is being asked. This input current. So try from your end once.
Yes, sir. Thank you, sir.